Hello, and welcome to this section on memory. In this video, we'll be learning about unique pointers. We have touched on this subject before, but now we're going to take a deeper look. The C++ standard library has a lot of additions and modifications since the days of old to try to make memory management a bit easier. Since C++ is a systems programming language meant to run on any machine, they leave the details of memory management up to the developer. In this section, we are going to look at the many features defined in the memory header. The standard unique pointer is a smart pointer that owns and manages another object through a pointer and disposes of that object when the unique pointer goes out of scope. It provides us with a basic yet powerful tool for managed memory in our programs. The unique pointer class takes a pointer to some memory of type T, or an array of type T, and also an optional deleter. You may recall that we used deleters in our first project to automatically handle the memory acquired by calling our libcurlc library. A unique pointer can manage a single object created with new, or a dynamically allocated array of objects created with the new array operator. It can also not manage any objects, which is an empty unique pointer and is equivalent to the null pointer. A unique pointer and the object it owns can be moved to another unique pointer, but it cannot be copied. A const unique pointer cannot be copied or moved. An optional deleter can be supplied to the constructor, which will be invoked either when the unique pointer goes out of scope or on a reset call. This can be useful for making sure that extra cleanup steps are fulfilled, especially for the older C library objects. Let's take a look at some examples. Okay, so the first thing I'm going to do for my example is I'm going to create a new class called student. And this student is going to have an ID, a first name, and a last name. We've done this before, so if you've already written this, you could just copy and paste it from there. So my student has two constructors, one default constructor, and one constructor that takes in the ID, a first name, and a last name. And then I'm going to also create the getters for the ID, the first name, and the last name. So this will finish up the student, and we can now move on to the main program here. So the next thing I'm going to do here is I'm going to define another class called the student deleter, and it's going to have an operator overload for the callable operator. So here we have our student deleter, and in our callable operator, it takes in a student pointer called s. We print that we're deleting the student, and then we go ahead and delete s. So really this is not necessary, but we can show that we can add some extra deleting functionality with this cout. It's good for debugging as well. So the next thing I'm going to do is I'm going to create 3 students. The first way I do it here with the unique pointer student is I just use the unique pointers constructor, and I say create a new unique pointer called student called s1, and I'm passed to it a student created with the new operator, because this will return a student pointer. The next way I do it is to use the make unique function, which is provided in the standard library, and it's a templated function. So I say make unique, and I pass what kind of type I want. Then I pass the parameters that I want it to forward to the constructor for student. So in this case, it's going to forward the parameters 2 for ID, Mike for first name, and Richards for last. This will then make a unique pointer that holds a student. Finally, I'm going to make an empty student here with the make unique student. Next, I'm going to create a student deleter, and I'm going to create a third student called James, which is my name. Finally, I'm going to create a unique pointer with this student that I've created and the deleter, and I'm going to pass both. Notice that when I create the unique pointer, I have to pass in both the type of the pointer, which will be a student, and the type of the deleter, which will be a student deleter, which matches, of course, this class name right here. And I pass in the actual value, James, and the student deleter, D. And I could also create a empty unique pointer called null pointer, which points to nothing. So this is how that would work, and let's go ahead and run this. So we can see that when I delete using my student deleter, it will actually output that to the screen. And if I run this through Valgrind, we can see that I had 6 allocations and 6 frees. Even though I did not have to do that myself, the unique pointer handled all of the freeing of memory for me, and we could see that no leaks were possible.